We were talking about rate of chemical reactions, and we
Yes.
stopped at catalyst. I want to continue with catalyst to finish this topic, rate of chemical reactions. Then we will continue with solutions, aqueous solution. Okay, we will talk later. Okay, let's continue with this catalysts. You have heard about catalysts. Catalysts are chemical substances. They can change the rate of reaction. Not only change, but they can only stop the rate of chemical reaction. Their role, their function is to speed up the rate, but without being used up in the chemical reaction. So they are not consumed uh, during chemical reactions. Okay, catalysts never produce more product. They only produce the same amount, but more quickly. Here is given a graph, a diagram. This diagram is called enthalpy profile diagram. I don't know if you have learned about it. Enthalpy profile diagram is called this diagram, this graph.
Yes, I've learned about it before, but we didn't really go too in depth in it. So
Okay, so if we have a chemical reaction, a chemical equation, in this graph, in the first line, we will write the reactants, their chemical formulas. In the second line, we will write the chemical formulas of the products. And these curves represent the activation energy. Because activation energy is the amount of energy that reactants, the particles of reactants, must absorb. So reactants absorb energy. This energy is called activation energy. So this curve represents activation energy. But here we have two curves. The first one with the largest difference of energy is the activation energy without a catalyst, while the second one is the activation energy when we use a catalyst. So the function of a catalyst is to reduce the amount of activation energy of a chemical reaction. So when catalysts reduce this amount of energy, the reaction will be faster because more particles will have the activation energy. So activation energy is the energy needed to give a successful collision and a successful reaction. Okay, many catalysts are transition metals. So they are solids. For example, nickel. Nickel is a catalyst used in the production of margarine. We can hydrogenate the vegetable oils using nickel, this metal, as a catalyst. The second one is iron. Iron is a catalyst used in the production of ammonia. This process is called Haber process. I will write here the chemical equation of production of ammonia, of course. Nitrogen reacts with 3 mole of hydrogen and produce ammonia, 2 moles. In this reaction in industry, we use as a catalyst iron. Look, Fe, the symbol of iron. This is the chemical reaction or called Haber process in industry. Another catalyst that is a metal is platinum. Platinum is a catalyst used in the converters of cars exhausts. The function of platinum as a catalyst is to convert carbon monoxide and nitrogen monoxide into carbon dioxide and nitrogen. I will write here the chemical reaction. I will write here the reaction. Look, carbon monoxide is the formula. Nitrogen monoxide. If we use catalyst platinum as an exhaust, will be produce carbon dioxide and nitrogen gas.
Please, can you pass the water? How can you spit into your water and drink it?
Okay. This is about catalysts. Catalysts are really important in industry because we can produce more quickly the products, saving time and money. Catalysts reduce the pollution. And you have learned there are also some important biological catalysts called enzymes. You have learned.
Yes, sir.
Okay, here are the key concepts, the most important concepts we learned in this topic. And I want to fill these questions. Can you? We will find the missing word. The higher the temperature, the
faster the rate of the reaction.
Yes. At a higher temperature, particles have
more energy.
Yes. This means they move
faster and are more likely to collide with other particles. The higher the concentration, the faster the rate.
Yes. The second one, B, at higher concentration, there are
more particles in the same amount of space.
Yes. This means that particles are
more likely to collide and so increase the rate of reaction.
Okay, very well. 3A.
The faster the rate of reaction.
Yes, at a higher pressure.
In which particles becomes
the space
becomes smaller.
Yes, smaller. Yes. This means that particles are
closer together.
Yes, they are closer together, increasing the frequency of collisions, and so
increase the rate of reaction. Take the water now.
Okay, very well. They are completely correct.
Thank you.
How fast can you answer these questions?
Okay. Why don't all collisions between B?
Yes, not all the particles collide with enough energy because not all of them have this activation energy.
Yes, the next question, please. Okay, why do most reactions between a fast rate and a...
What do you think?
I think it's C.
Yes, the concentration of reactants decreases. This is the reason.
C.
No. Look. No, actually, it's not correct.
Okay.
I don't know why here is with tick, but it's not correct. Actually, the steeper the slope, the faster is the chemical reaction. If the slope is shallow, the reaction is not fast. And if we don't have a slope, if we have a flat slope, it means the reaction is. Ooh, is not true. Okay, the answer is for this is correct. A is correct, B correct, D correct, C is not correct. I forgot that the question is asking the wrong statement.
Okay.
Okay,
Yeah.
so you mean the wrong answer, the wrong statement. Okay, which of these is not a method for measuring the rate of reaction? It's not.
D. D.
D, measure the change? Yes, okay. Which of these will not speed up the rate of reaction between a strip of magnesium and hydrochloric acid?
A.
A,
Yes.
yes. Why does a higher concentration increase the rate of chemical reaction?
B.
B,
Yes.
but how it asking why a higher concentration will not change the energy of particles.
Oh, concentration. D.
Yes, D. It increases the frequency of particle collisions. Okay, what does a higher temperature increase the rate of chemical reaction? This is about energy.
A.
ASA. It increases both the frequency because when particles get energy, they will move faster. Another reason here is the energy of particles or the number of particles with the activation energy is increased. Okay,
Okay.
what does breaking up a solid increases the rate of chemical reaction?
C. It increases the surface area.
Yes, yes. Why does a catalyst increase the rate of chemical reaction?
C.
Oh, it extra energy. A C? No, I told you I explained it now in this, let's say today, in this topic about catalysts. I told you they reduce the amount of activation energy. Catalysts. Catalysts reduce the activation energy, the amount. So this is the way how they speed up the rate of chemical reactions. Okay, which of this is not a benefit of using a catalyst? It's not.
B.
Yes, B. The amount of the products will not change. Okay, very well. Now we will continue with concentration of solutions. Have you learned anything about solutions? Or do you know anything about them?
I know they're made of a solute and a solvent.
Yeah, okay, very well. You must probably have learned about mixtures.
Yes.
Okay, we have heterogeneous mixtures and homogeneous mixtures.
Okay.
Yes, solutions, aqueous solutions, are type of homogeneous solutions. So solutions are made of solute and solvent. So I will write here. We have solute plus solvent will produce solution. Solute is the substance in minority in mass in the solution. Remember, solute is the substance in minority in mass, whilst the solvent is the substance in majority in mass in the solution. So if we have, let's say, 10 grams of sugar and 50 gram of water, the solvent, the sugar will be the solute, solvent is water, and solution will be 60 gram, because solution, the mass of solution is solute plus solvent. Okay, is it clear?
Yes, it is.
Okay, so this is about solutions. Another important, let's say, property of solution is their concentration. Okay, concentration expresses the amount of solute in the solvent, but depends on how we express the amount of solute, we will determine the type of concentration of solution. One type of concentration of solutions is mass percentage concentration. This is mass percent or mass percentage concentration. Okay, this mass percent or mass percentage concentration describes the amount of solute in grams, the mass or percentage concentration expresses the mass of solute in 100 grams of solution. Here I write so for solute, and MP for solution. This mass or this percentage concentration is expressed in percentage. This is why it's percentage concentration. This is the general formula of calculating the mass percentage of or percentage concentration of solutions. For example, if 10 gram of table salt, sodium chloride, is added to 90 grams of water, will produce 100 grams of solution. What will be the concentration, the percentage concentration of this sodium chloride? 10 over 100 times 100% will be 10%. This is the mass, the percentage concentration. This is as a concept. This is an important concentration, one of most important concentration. Here we have an exercise. Glucose is the main substance in a solution, you know, and the question is how many grams of glucose must be dissolved in water in order to prepare 500 grams of solution with concentration 5%. So
Yes.
you can use a notebook to take notes.
Okay.
This is how I will use the formula, the general formula, to find the mass of solute. Look, the percentage concentration is equal mass of solute over mass, let's say, of solution times 100%. What is the percentage? Look, the percentage concentration, 5%. What is the mass of solute? This is what we will find out. The mass of solution is 500 grams times 100%. So 5 times 500 over 100 will be the mass of solute. 5 times 500 is 2,500 over 100, it will be 25. So 25 grams of sugar or glucose. Is it clear?
Yes.
Now this is the solution. Okay, let's solve the exercise 2.
Okay.
Wait. Is your first time with these types of exercise? Have you ever learned?
This is my first time doing like calculating concentration of things.
Okay. They are useful because concentration solutions and their concentrations are really important in chemistry.
Okay.
So here is the exercise. Solder, an alloy consisting of lead and tin, is used to join metals. 70% by mass is lead. We will find the amounts of lead and tin in 400 grams of this alloy. This is simple. Alloy is a solution, is another type of solution. It is not aqueous solution, but it is solution. Why solution? Because it is a homogeneous mixture between two substances. They are both metals, so alloys are homogeneous reactions. Now, firstly, let's find the mass of lead in this alloy. Look, mass percentage concentration is the mass of zinc over the mass of alloy, mass of solution, times 100%. We want to find the mass of zinc. Look, mass of solute or mass of zinc will be percentage concentration times mass of alloy over 100%. The percentage is 70%. The alloy, the mass 400 over 100. Wait, here we have a calculator. So 0.7 times 400 will be 280 gram of zinc. What will be the mass of tin? Of course, the mass of tin will be 400 minus 220, 280. The mass of tin, the chemical symbol of tin is Sn. It will be the mass of alloy minus the mass of zinc. 400 grams minus 280 grams the mass of zinc is 120 grams of tin. This is the solution of the exercise. Is it clear?
Yes, it is.
Okay, now we will continue with some exercise. Another type of exercise, of course, more difficult, because these exercises are, let's say, relatively simple. Okay, here we have another exercise. 22.4 liter sample of hydrochloric acid. Have you learned about molar volume? Molar volume.
No.
Okay. Molar volume is the amount of volume of 1 mole gas, of any gas. Look, the symbol is Vm. This is M. I will write it again. This is the symbol of molar volume. Is the amount of volume of any gas, but in specific conditions. In STP, at STP, this amount, this value is constant. In 0 degree Celsius degree temperature and 1 atmosphere pressure, this amount of any gas, any gas always is 22.4 liters per mole. Mole of gas, of course, of any gas. So in this amount of water, 263.5 grams, is dissolved this amount of hydrochloric acid. So what should we find? What should we find? We should find the mass of hydrochloric acid. Do you know the formula of hydrochloric acid?
No.
HSL, hydrochloric acid. This is the chemical formula. Okay, first of all, we must find the number of moles. Number of moles of any gas, here is for hydrochloric acid, is mass of hydrochloric acid. Wait a second. The volume of hydrochloric acid over the volume, the molar volume. So what is the volume of hydrochloric acid? 22.4. 22.4
22.4.
liters over 22.4 liters per mole is 1. So we have 1 mole of hydrochloric acid. But in this type of concentration, we don't need the number of moles, we need the mass of solute. Have you learned the formula, the relation between number of moles and mass, molar mass? Are important concepts. Look, mass of a substance, is number of moles. The symbol of number of moles is N. This symbol is number of moles. M is mass. M lowercase, N lowercase. This is number of moles times molar mass. M uppercase is molar mass. How can we find the molar mass of hydrochloric acid? We can use periodic table. In periodic table, we have the molar masses of the elements. The molar mass of hydrochloric acid is molar mass of hydrogen plus molar mass of chlorine. If we look at periodic table, we will find that the molar mass of hydrogen is 1. The molar mass of chlorine is 35.5. So the molar mass of hydrochloric acid will be 36.5 gram per mole. So N, we find N here, 1 mole. Look, 1 mole times molar mass, 36.5 gram per mole. The mass will be 36.5 grams of hydrochloric acid. Now, after we found out the amount of solute, we can easily find the percentage concentration. Look, I will go to another page. Let's write them again. The mass of solute, we found it, 36.5 grams. The mass of solvent, this, look, this is not the mass of solution, is the mass of solvent, because we know the mass of solution is solute plus solvent. Here I will write solve for solvent is 263.5 gram. The mass of solution, or we can calculate it using directly in the chemical formula. We want to find the concentration. Look, percentage concentration is mass of solute over mass of solution times 100%. Here, mass percentage concentration is mass of solute over mass of solute plus mass of solvent times 100%. So mass of solute 36.5 grams. This is 36.5 grams plus 263.5 grams times 100%. So this will be 36.5 and look, 36.5 plus 36.5 plus 263.5 is 300 times 100%. Now the last calculation, 36.5 over 300 times 100% is 12.16 or 12.1, about 12.1%. This is the percentage concentration when we dissolve 22.4 liters of hydrochloric acid in 263.5 grams of water at STP. STP means standard temperature and pressure. Standard temperature and pressure. And remember, at STP, 1 mole of any gas, any gas, always is 22.4. 22.4. Is it clear? Any question?
No. Except, excuse me, may I please have the
Yes.
notes after class?
Yes, of course, you can.
Okay, thank you so much.
I will send. You are asking here in this. Only he in active inspire or both the previous ones?
No, just today's one.
Okay. Wait, I will copy your address because you wrote me okay, breath. Okay, I will find another exercise. Here we have another exercise. What mass of water must be added to 200 grams of 30% sodium hydroxide in order to make 6%. Okay, this is a little bit difficult. But if we know, if the concept of percentage concentration is clear in our mind, we can easily solve this exercise. So what we have 200 grams of solution, 30% of sodium hydroxide. The chemical formula of sodium hydroxide is this one. So first of all, we have to find the mass of sodium hydroxide in this solution. So the mass of solute, the mass of sodium hydroxide will be percentage concentration times mass of solution over 100%. The concentration is 30%. So 30% times the mass of solution, 200, over 100%. So it 30 times 2 is 60 grams. Because we will simplify 100 with 200, this is 2 times 30, 60 grams of sodium hydroxide. So we have another solution here. The solution that we want to prepare must be with concentration 60%. So if we have here a solution, let's say 200 grams, we will pour here another amount, let's say X amount, X grams of water. Look, when we will add water, the mass of solute will not change. The mass of sodium hydroxide here, that is 60 grams, will not change. Why? Because we will add water. Do you understand it? Because it's really important. When we will add water here in this, let's say in this container, only the mass of water will change. But what is water here? Water is a solvent. So the mass of solute will not change. What we want to prepare, we want to change this, to change the percentage concentration of this from 30% into 6%. But since the mass of sodium hydroxide will not change, we can write the expression as follow. Look how we must write the expression. I will write with another color. Percentage concentration is mass of solute, sodium hydroxide, over mass of this solution. This is solution plus the mass of water that we must add here times 100%. This percentage must be 6%. Mass of sodium hydroxide, 60. We found it. The mass of solution, 200. grams, and mass of water that is added is X. We don't know it, we will find it. So I will copy this, wait. Uh, so 6%, I will simplify 6 with 100%. This will be 0.6 equal with 60 over 200 plus x. 0.06 times 200 plus x is equal with 60. So we need to make some calculations, or we can simplify again. We can simplify 60 with 0.06. This will be 10, and this can be 0.01. Look, it can be 10, and this 0.01. And 0.01 times 200 is 2 plus 0.01 times x, 0.01x with 10, and the 0.01x is 10 minus 2 equal with 8, and x will be 8 over 0. Sorry, I stopped. Wait, I will I'll write it again. Wait. I will write it here because I don't have space enough. X is 8 over 0.01, and as I know, it will be about 800 maybe. Look, wait, 800 grams. So look, we must add 800 of water in order to change the concentration of this solution, the first solution, from 30% into 6%. Do you get it?
Yes, I do.
I will send you some exercise.
Okay.
To learn them better. So the best way is to solve exercise on your own. Wait. So here we have a solve exercise. The question is very similar. We will find in this exercise how many grams of water must be added to 100 grams of 36% of hydrochloric acid to produce a solution with percentage 10%. So look, the mass of the percentage concentration is 36. We will find first of all the mass of solute. Solute here is hydrochloric acid. So 36 times 100 over 100, it will be 36, because look, this is simplified with this one. Mass of hydrochloric acid is 36. So we want to find in the next step, we will find the mass of water that must be added. What is the concentration of, or let's say the final concentration of solution? It is 10%. So percentage concentration here is 10. Mass of solute is constant, because when we will add water, the amount of solute will not change, because we are not adding solute, but we are adding solution. Solvent. Water is solvent. So 36 over 100 grams, the mass of first, let's say, of the initial mass of the solution, plus m or x, the mass of a known water, of the amount of water, times 100%. So these are easy calculations. We can simplify. This is 1, this is 10. 100 plus x is 360. Then we will find m or x, and it is 260 grams. I would like for you to solve this this exercise.
Okay.
Or I will send you some exercise.
Okay.
With the official website, and you can practice yourself. This type of exercise are really important in chemistry.
Mm-hmm.
So you will work with them. So for today, I think is enough. So this is all for today, okay? Are you hearing?
Yes.
Treasure?
Yes, I
Do you have
can.
any question?
No, I do not.
Any?
No.
Oh, so do you understand the exercise we done?
Yes, I do.
So very good. I I will send a little bit later the exercise, and what we done today, is so you can work on them, okay? Okay?
Hello? Yes.
Do you hear me?
Yes, I do.
Oh, I told you I will send a little bit later the exercise, what we did in this lesson, and so you can work on them.
Okay.
So thank you.
Okay.
Goodbye.
Bye.